Alright, since these videos continue to go down quite well, and since I'm quite enjoying them, we're just going to do some more. So here's the integration megamix of integrals. Let's pick a random one to 750. Oh, last time we had the issue of 1. I'm just going to keep it there because that was funny. So 295 is the first one. Uh, the chances of us running into an integral we've already done are very small still, thankfully. So we have this integral to do here, which immediately looks super, super easy. Just instantly, I mean, at an absolute minimum, you can just expand everything out in this and it just makes a polynomial, which you can then integrate. However, if you look at it more closely, you can spot something I think that's a little bit better. So this is plus 2x, we just copy it down, minus 1 all to the power 4 dx. So I think what we can spot here is that this is of the form. If this is, I'll put it down like this. Um, if you have something that looks a bit like f dashed of x, ooh, not c, uh, sitting next to f of x, really to the power of whatever you want. It doesn't really matter what this power is. That's not great education, but it doesn't really matter. Then you're great. And also you can have whatever constant you want here, it doesn't matter. So the derivative of this here is 2x plus 2, which is half of, or double of this. This is half of that. So I think if I just shove in a half, then I can just say it's going to be this integrated with a 5, except of course you would also bring the 5 down. So I also need to divide by 5. So I think it's going to be this. It is going to be the answer. So bring the 5 down, make a half here. The derivative of this is 2x plus 2 times by a half is x plus 1. The half that's left over there, and then you just have this to the power 4. And so that is the integral done. Again, you could have expanded this all out, but that would have taken a bit longer. Okay, so the first integral was not tricky. Let's see if we get a one that's going to take a bit longer. Sorry, I've already forgotten what the number that was. I've forgotten again. 457. 457. 457. There we are. So we've got a completely different integral here, which we will copy out here. So it's a fraction. My memory is not good today. I keep forgetting what 9 over e to the x. Apologies for all of this flipping around. It was definitely in open brackets. No, it wasn't. It was the square root. Root of e to the 2x. Was it minus 9 at the end or plus 9? I think I'm just being hopeful with minus 9. No, it was minus 9. Good. Okay, so here's another integral to do. This is a difference of two squares down here. This is e to the x plus 3 into e to the x minus 3. Doesn't immediately seem like that's going to be hugely helpful, although it could be. But maybe not. Something I did in a previous video was sort of get rid of this surd by timesing it top and bottom. That could certainly be a thing that might work here. You could immediately just go for a substitution here. If you made the substitution u equals e to the x. Firstly, you'd end up cancelling. Oh, that might work. So let's just try that. Maybe this doesn't work, but maybe it does. The reason that this is nice, though, is that when you differentiate this, obviously, it's just du equals e to the x dx. And then when you can divide by e to the x here, both sides, and then the dx just becomes du over e to the x, which creates literally just u squared underneath there. Because e to the 2x, of course, would be u squared from there with the du, and then this thing cancels, which is nice. You might also want to just consider flopping the 9. What words did I just say there? I have no idea. You might want to consider putting the 9 out here. And then I think this, I mean, we can write this as 3 squared. Oh, no, we can't. We can write this 9 as 3 squared. And now this looks very familiar to me, except I can't remember which one it is. So we'll get out the A-level formula book, again, as we so often do, because I can't remember any of these results. And we'll look for the integrating. I could have controlled F, but it never seems to speed me up that much, so I didn't bother. I think we're going to have to go to the further math section, right? Here it is. Here's all these guys. Is this one, which is arc cosh of x over a, it looks like. Yeah, so it's arc cosh of u. Yeah, cool. So it's 9. Let me just triple check that. U. Yeah, arc cosh. So this is 9 arc cosh. I'm not sure how PowerPoint. Is it 2 C's in PowerPoint? Yeah, arc cosh of what even was that? Was it u over 3? Because it's the 3 squared there. But of course, u is e to the x, so we're going to get e to the x from there. Ooh, e to the x from there instead. Good. So that's integral number 2 done. We'll delete that and we'll go for another one. So generate another one. Okay. I mean, I should have really changed this because this is gonna be too easy, right? I mean, actually, why don't we do this in why don't if we get an integral like this less than 100, new rule, you have to do it in a fancy way. So let's have a look at this. E to the 2x plus e to the minus x all squared. So fancy way, hopefully coming. I think it was actually plus e to the minus x, but then we can double check this. It's fine. E to the 2x plus e to the minus x. Yeah, it was. Okay, so cool. So, I mean, obviously, you can just expand this out, and then you can just integrate the 3 terms that you get at the end. That's not going to be tricky at all. Is there a nice, fancier way of doing this? Well, maybe there is. You could maybe consider, if I put this in like a square bracket, maybe, like this. We could factorize out an e to the x. No, that wouldn't be nice, would it? What about an e to the 2x? And make a 1 here. And then I guess we need to have like a minus 3x there. That's interesting. Not sure where this is really going. Obviously, when you square both bits of that, you get a 4 here. This is, I mean, no, I actually just can't be bothered with this integral. New rule already abandoned. New rule, we're just going to 100 because I can't bother to do the really boring ones. We will do one more, I think, in this video, 322. If you found a really interesting way of doing this integral that's fun, tell me about it. Next one is the integral of 1 over cos to the power 4. Cool. Obviously much more interesting. So we'll do it. This is, I mean, there's a few things that we can immediately consider here. This is sec to the power 4 is the first thing we can say. Now, sec to the power 4 of x. We can start thinking about some trig identities. I guess 1 plus tan squared equals sec squared. Means that sec to the 4 is 1 plus tan squared all squared. I guess we could say. Would be what seems like a reasonable way of doing this. The reason I think that might be reasonable is because when you expand this guy out, I know how to integrate 1, obviously. I know how to integrate 2 tan squared. And so all I would need to do is know how to integrate tan to the 4, which, I mean, maybe that's good, maybe that's bad. I don't know this integral off the top of my head. I know it's this one, can I just say, okay, so imagine this thing is the thing being integrated because it's sec to the 4. Obviously that integrates. Tan squared integrates because you can use this again, right? You can say tan squared is sec squared minus 1. And then the integral of sec squared is tan. And so that all works out quite nicely. The 1 cancels, which is nice. Now tan to the 4, I don't know whether I'm so good at integrating. You could consider some kind of, I think that would get you going around in circles, would it not? I was thinking tan to the 4, you could write a sec squared minus 1 all squared, which gives you a sec to the 4, and then you can say this whole I equals I thing. I imagine that I'll end up with a tautology if I try that. But maybe, is it worth even considering and looking at? Maybe it's worth considering, but the fact that those things cancel makes me dubious of this method. But let's go for it anyway. So tan to the 4 from over here. This is so going to give me a tautology, but that's just, it will give me time to think of an actual way of doing this. Might be bad, might be good. So it will be sec squared minus 1 all squared, which is sec to the 4 minus 2, okay, sec to the power 4x. But yeah, because it's plussing, the i's just cancel. Yeah, the i's just cancel. It doesn't achieve anything. Okay, so we can't use that. Okay, so we could consider staying with this and think about a different way of doing tan to the 4. So it's, I mean, it's sine to the 4 over cos to the 4. Is that helpful? I don't know. It's interesting that you have a over cos to the 4 object here still. Don't know. Okay, so maybe not. Maybe this doesn't lead to anything really particularly good here. We could consider writing sec to the 4 as sec squared, and then doing some parts because sec squared just integrates to tan. So maybe that's something for us to consider. So let's think about that instead. So, okay, so let's do sec. And this is kind of what you do in integration, of course, and this is kind of the point of me doing these on the fly, is I've got this kind of checklist in my head, and you just kind of run through it. Sec squared integrates to tan, and you just keep trying stuff until something works. So the first two times like this, so that's the integral of one of them, and then leave the other one alone. And then we're going to take away the integral of one of them, and then differentiate the other one. Now sec squared differentiates to, well, it's cos to the minus 2, so that's going to be a minus 2, so that'll make it plus 2 here. Cos to the minus 3. I'll just write it as cos because why not? And then we need to times by the derivative of cos, which is minus sine. And so that will turn back to a minus, I believe. Okay, and then we just have to hope that this integral goes a bit better than the previous one did. So, okay, let's try combining all these things together. So this is sine over cos, obviously. This is sine, so that makes sine squared over cos. And this is cos on the bottom. So this is sine squared over cos to the 4. Now, the reason I'm keeping this cos to the 4 is because, again, it's turned up a couple of times now. It's from the very start. So I would have thought what we can do here is we can call this I because that was the original integral. And now this thing here is, so if I just put this up here somewhere. Now what my plan here is to say that sine squared is 1 minus cos squared, which means this is the integral of 1 minus sine squared over cos squared. Sorry, sine squared is 1 minus cos squared, which means this is 1 minus cos squared over cos to the 4, which is sec squared, I think, and dx. That should be a dx here as well, sorry. I don't know why I'm doing this. Everyone knows what I mean, but just for completion, so that all should be like this. Okay, now this is great because this is the original integral, and there's a 2 here, so they don't just cancel. And the integral of sec squared, as we've already seen, is just tan. So this is 1 minus, sorry, I equals this stuff, minus 2i plus, because minus minus, 2 tan x. And then I think we can just rearrange this, and we'll end up with 3i over here, so we divide all this by 3. And we should have what I think is an acceptable answer to that. And I hope I haven't made a mistake there. But yeah, that seems like a decent enough method. So yeah, that seems okay. How long are we going? Just 13 minutes. Oh wow. Okay, so yeah, let's do one more. 285. It's selected some very low ones, but I don't want to ever break the rule and not do one that's given to me. Okay, so this looks fun because of this power up here, making it a bit different. So let's do. We will finish on this one. We will finish on this one. So let's do. What is this? 3x squared into something. Memory is not doing well today. I'm having to go back and forth quite a lot of times. 3x squared into. Sorry, let's bring this up. 4 minus 2x cubed. And then that was all to the power 3 over 2, I believe. And then we just double check. 3x squared, 4 minus 2x cubed into 3 over 2. Good. Okay, so things to do, things that we can do here. Now, okay, I immediately regret doing this integral because it's trivial. Thinking about the checklist that was going on in my head, it just immediately satisfies one of the things that I see. Like if I see a product here, which is obviously what my brain sees, the first thing that I check is one of these things the derivative of the other, preferably the one that's not got the power with it. And it is, right? Like this derives here to minus 6x squared, which isn't this, but it is that to just some power here. So this is a half here to compensate for that into 4. The 4 doesn't matter because it differentiates away, so that's irrelevant. And then you raise 1 to the power. And the last thing to check is, okay, well, the power comes down, right, times by 5 over 2. So we need to cancel that by times by 2 over 5, which cancels that too. So I think if we just shove a 5 here, or no, I've completely, sorry, a 1/5 is what I meant, sorry. A 1/5 here, I think we're completely fine. Because this comes down and creates a 2, which then times by 6x squared. Oh, no, I've gone the wrong way. And I've also missing a minus. I'm really terrible at this. I'm good at spotting that it's the reverse thingy, and then bad at actually getting the numbers to work. So when you times by 5/2, no, I was right the first time. When you times by 5/2, you get a half here, which halves this 6 to a 3. The x squared is good, the negative cancels that, and I think we're just done. So yeah, that was not interesting.